Hi everyone. So how you are doing? Enjoying? I think vacation is over and date are also out. When will be the board? It is in May, so you have lot of time to revise. Hope you people are studying sincerely. So in last class what we have done? We have done force on a current carrying conductor in a magnetic field. That means when you keep a conductor in which current is flowing and you will keep that conductor in a magnetic field, then how it is going to experience the force. So in last class we have seen that. In today's lecture it is very important. We are going to see what is the direction of that force. So we have to find out the direction of the force. Okay. So I have kept this as separate because it is itself like so much to analyze, think, and you should concentrate because this is the main part of this electromagnetism, you can say, because these hands rules are very important to find the direction of the force, and kids find it little bit difficult, you can say, twisting hands, doing that. So I thought of giving this particular section, hand rules, in a separate video. First, before going to directly to the rule, and I think you people know what rule I am talking about, that is Fleming's left hand rule. Before going directly to that, let us try to understand actually what is happening. Why this rule is helping us to find the direction of the force. What exactly this force is and how it is acting, actually in which way it is acting. In last experiment we have seen a horseshoe magnet, north pole, south pole. This is your horseshoe magnet. We have used this, so one is north, one is south. So suppose this is your north pole, this is your south pole. So magnetic field will go from now north and terminate in south. Suppose wire is this, and in this wire current is flowing. So this is a current carrying wire. So if it is a current carrying wire, so it will experience there will be magnetic field around this. Already we have studied, so it will behave like a electromagnet. And in last lecture also we have studied when current is flowing and needle is there. So this electromagnet, when current will flow in this where it behaves like a electromagnet, so it becomes a electromagnet. So this electromagnet will apply force over here because of the magnetic field, that is your magnetic force. So that's why this needle, the north pole of the needle, that will deflect, and in return this will also give the opposite, according to your Newton's third law, equal and opposite force will be applied by this needle on this electromagnet. So now let us see this north pole, this is your south pole, this is your current carrying conductor. So that means first this north pole and south pole, these two poles, like this horseshoe magnet, it will now experience, it will give a force on this, like this wire will experience a force by this magnet. It will either try to pull or push the wire. Okay. Similarly, this wire also, what this wire will do, even this wire is now electromagnet, so definitely it is going to apply force on these two magnets. Okay, or you can say simply this magnet. So let us see how it is going to apply the force. Okay, I am erasing this. Now I am concentrating on the electromagnet first. As we have studied in straight current conductor, so around this right hand thumb rule there will be magnetic field like this, and it is like this. This also we have studied, if current is flowing, so this is the direction of thumb and this is the finger. This will give you direction of the magnetic field like this. Okay. So now we have to understand what these field lines are. These field lines are nothing but this is the actually when we are keeping the compass, the north pole is getting deflected. So that means force experienced by the north pole of the needle. So that way only we are drawing this magnetic field lines. Okay. Now let us find out what is the force direction. Since this is an electromagnet, there is magnetic field and it will give a force. Now let us try to understand what is the force on this magnet. So this is your north pole. So at this point, what is the force direction? As you can see, the arrow mark is over here. That means when you are keeping your compass over here, north pole is getting deflected like this. So can you make out what is the direction of the force? This is like this. This is your force direction. That means it is out of the board. At this point, please imagine children, at this point current is flowing like this. So this is the current carrying conductor. At this point, your direction of force. So at this point, this is the arrow direction. So now force direction is this. That means it is out of the board. Come to this point. As you can see, the arrow is towards inside. So if it is towards inside, this arrow indicates the force experienced by the north pole, because these field lines we have drawn, as for the deflection of the north pole. So that means this is the way north pole is experiencing the force, but this is your south pole. That means it is opposite to that. This is opposite to that. Is it clear, children? So this south pole will experience the force in outward direction. See, this is also outward direction, out of the board. Now force experienced by this magnet is out of the board. If force experienced by the magnet due to the current carrying conductor is out of the board, what about the force experienced by this wire because of the magnets? As we have already discussed in my last lecture, it is equal and opposite direction. That means this will be inside. This will be inside. Little bit of tricky, little bit of difficult. Please try to understand this concept. Why we are studying Fleming's left-hand rule? We must first understand why we are studying Fleming's left-hand rule. How it is making our job easier. Then only we will understand the importance of that rule. Then only you can concentrate on that rule. Okay? So, is it okay, children, or I will repeat? At this point, see your compass needle is showing in this direction. That means it is outward direction. Force experienced by your north pole of the compass needle in outward direction, out of the board. This is the force given by this wire on the magnet. Similarly, here also, north pole is inward. That means south pole is expressing the force outward direction. That means your force experienced by the magnet due to this electromagnet is in outward direction. Then what is the force direction of this electromagnet experienced due to this magnet? Just reverse of it. That means that force will be inward for this current carrying conductor. This current carrying conductor now experiencing a force in inward direction. Okay, here comes, because this is so difficult, this is very tedious. So here comes the Fleming's left-hand rule. What is this Fleming's left-hand rule? Fleming's left-hand rule. What is this? Everybody knows. You people have studied, I know. So keep your thumb, forefinger and the central finger, okay, in 90 degree, perpendicularly hold this. So your thumb, so this is your, let me draw first. This is your thumb, this is your forefinger and this is your central finger, okay. So your forefinger gives the direction of the magnetic field. So it gives the direction of the magnetic field, okay. And your this finger, central finger, gives the direction of the current. So your thumb gives the direction of the force. That means direction of the force experienced by your conductor, or you can say the conductor will move in this direction. So this is the direction of the motion of the conductor also. Clear? So this is the direction of the force experienced by your conductor. You can say F, B and I. FBI. Easy to remember? F, B and I. Or you can say father, mother, child. C for child. Okay? Father, mother, child. Easy to remember. So now see, in the previous case, is it clear now? What we will do? Use your left hand, and first what you will do, use these forefinger first in the direction of the magnetic field. So first align this finger along the direction of the magnetic field, then use your central finger for the current, then automatically you will get your direction of the force. So let us try to find out. Just in the case of previous case, just now we have seen force will be inward into the board. So what is the direction? So this is your north pole, this is your south pole, just now we have seen, and this is the magnetic field direction and current direction is this. So this is your current direction, this is your magnetic field direction. Now what we will do, stretch your hand, all are perpendicular to each other. Okay. Now this is your magnetic field direction. So this is in the direction of magnetic field forefinger. Current is in upward direction. Then what I will do? Current is in upward direction like this. See the twisting. Now magnetic field. Now magnetic field. So this is your current direction. And what about this thumb? Now thumb is into the board. Now thumb is into the board. Is it clear? So we are getting the correct direction. Clear? How your force is in the inside towards the board. Is it clear, children? Is it clear? Can you people view this? Okay. So this is your, now force is inside, we have seen. So this is your Fleming's left hand rule. Clear? But another one more thing, very important. In all the problems and in books, all the example, usually question will be like this. Usually question is, it is perpendicular. But when suppose your conductor is placed like this, whether your Fleming's left hand rule will applicable over here? Yes. Here also you will use the same Fleming's left hand rule. Okay. It doesn't matter what is the angle. You have to align and you will get your force direction accordingly. Clear? Now, I think it is again tedious. At least you have to twist in so many ways the fingers, and twisting has to be again proper. So you have to keep on twisting. It is Fleming's left hand rule is helping. How we have now seen the force going inside the direction. In the first, when I have tried to make you understand why we are using Fleming's left hand rule, how it is helping to make our job easier to get the direction of the force. So Fleming's left hand rule is done. So it is helping to get your direction of the force very easily. Now I want to explain another rule which will be much more easier than your Fleming's left hand rule, that is your right hand palm rule. Please children, this is my request. Every case you can see how it is very helpful. No twisting of hands, no confusion. Very, very important rule. Right hand palm rule. Please children, please concentrate. Okay. Now this is your thumb like this. This is your palm, right hand palm. So thumb is like this and all the fingers will be like this. So this is your thumb. Okay. So what you will do first, all the fingers, keep all the fingers in the direction of the magnetic field. Keep all the fingers in the direction of the magnetic field. Okay. And keep the thumb in the direction of, this is your right hand. Okay. Keep the thumb in the direction of the current. And your palm, in which way this palm will face, that is your force direction. Interesting? Interesting. Now we'll try to see how it is helping in the previous case. Because we have seen all the twisting. This, and then this is your force direction. That we have studied just now. Now we'll see how it is helping. See, this is your magnetic field direction. This is north, this is south, this is your current direction. So what we'll do, we'll use our right hand now. So these fingers towards the magnetic field. So this is your magnetic field direction. So all the fingers now in the magnetic field direction. Am I visible to you? Am I correct? Am I visible? Can you people see my hand? Can you people see my hand? See the direction of the magnetic field. See the direction of the magnetic field. Okay? So magnetic field is in this direction here. So now my fingers, all the fingers in the direction of the magnetic field. Current direction, see the current direction, thumb is the direction of the current. Thumb represents the direction of the current. So current is going like this. So current is going like this. See the palm. This is your palm. In which way palm is directing? Towards the board. So it is inside. It is inside. So your force is inside. Am I clear, children? Am I clear? Is it easier than your Fleming's left hand rule? Magic rule this is. No twisting of fingers. No twisting of hands. No need to practice. You can practice. You can apply. But this is also another rule which will help you to get the direction of the force very easily. Fingers in the direction of the magnetic field. Thumb in the direction of the current. And your palm direction. The palm. In which way the palm faces, that is the direction of the force. Let us see another example how it is helping us. As you know, this is, that means magnetic field is inside. Cross mark means magnetic field is inside. Already I have told you this thing. Okay. So this is your magnetic field, uniform magnetic field. Okay. Now current is placed like this. So this is your where current is flows like this. Current is flowing like this in the conductor. Tell me the direction of the force. Find out the direction of the force. In which way? First we will apply the Fleming's left hand rule. Let us see Fleming's left hand. So this is your forefingers. It is inside. See, it is inside now. And current is up. See, current is up. See the fingers. Forefinger is into the board because of the magnetic field. And current is in upward direction, your central finger. See the direction of your thumb. See the direction of your thumb. In which way? So can you people see? In this case, so what is happening? Again I am trying to explain. Magnetic field inward. See the magnetic field inward. My forefinger, inward direction. And current, central finger, is upward. What is stretch? 90 degree, 90 degree, 90 degree. See the things. Now see, in which way my thumb is directing? It is in this direction. So force in this direction. Now, I think you people have realized how much twisting is required to get the direction of the force in this case. Now let us try to understand same thing. Let us find out how it is helping us. Right hand thumb rule, right hand palm rule. Fingers towards the magnetic field. So it is like this. Thumb, upward direction. What is the palm? Like this. See, palm is facing in this direction. So force in this. Is it simple? It is very simple. Hopefully people will realize, and please children practice Fleming's left hand rule, but please practice this also. Maybe you will leave Fleming's left hand rule and you will start practicing with your right hand palm rule. Is it clear, children? Should I repeat this example again? See, this is inward. Cross means magnetic field inside. Thumb is the direction of the current. See the force. Force direction, palm. The direction towards which your palm is facing, this is your force direction. Hope I am clear and making your job easier. Making it easier to get the direction of the force, so that you people will enjoy this chapter. You people will not get scared of this chapter. You people will not be scared of physics. You people will not be scolding teachers, physics teacher, because I got scolding so many times. How and why you are teaching this boring subject? This is not the subject that we are relating to our life. This is not helping us. This is the common complaint from the kids. Why we are studying physics? Everywhere you can see physics here. So please start enjoying your subject. Don't think you are reading for the exam purpose. Then it is definitely making your life hell. Because this is difficult, concept is difficult, visualizing physics is very difficult, but if you once started visualizing the physics, I know you will enjoy your physics. So with this note, physics is easy, getting the direction of the force by the current carrying conductor is also very easy. So I have to stop here, and in my next lecture, we'll go to DC motor and all the subsequent portions of this chapter. Hope you have enjoyed this lecture. In some way I have helped you to make it easier. Any problem, reach out to me in my website address. My number is there, so it's up to you. If you find it very easy, if I have helped you in some way, please leave a comment, so it will give me a boost to work hard and to prepare the content, and that content, again sharing that content with you. So thank you so much. Thank you for watching.